I'm going to work a couple of these electron dot notations because of ones that I've been getting emailed to me. These are common ones that are missed. First of all, carbon. Carbon on my periodic table has how many valence electrons? 4, right? It's in group 14. It has 4 valence electrons. So based on my dot procedures, I should have 1, 2, 3, 4. Remember that we talked that our symbol we used was XY, and we said 1, here's 2, where dot goes. Here's 3 dot. Here's 4 dot. 5, 6, 7, 8. They followed that order based on Hund's rule for the PX, PY, and PZ. This one represents the S. Okay? So that's why carbon has 2 right here, because the 1, 2 of the S over here. Now we look at helium. Okay? Helium is in group 18. Okay? Group 18 tells us that we have 8 valence electrons. Is that the case for helium? Why not, Olivia? Because helium only has 2. So helium fills its outermost energy level with 2 electrons. So I go at the 1 spot and the 2 spot. There is helium. Next one is aluminum. Okay. Taylor, how many valence electrons does aluminum have? 3 of them. So I am going to put a dot in the 1, a dot in the 2, a dot in the 3. Evie, what about beryllium? How many valence electrons? 2 valence electrons. 1 spot, 2 spot. Boron, Michelle, how many valence? 3. So I have the 1 spot, the 2 spot, and the 3 spot. Now, it gets a little bit different. Gets a little bit different when we talk about the ions. Okay? Because I have to construct my sulfur first, and I know that sulfur is in the oxygen group, so it has 6 valence electrons. So when I put that in there, here's 1, here's 2, here's 3, 4, 5, and now I can double it up based on Hund's rule to 6 right there. Now, the whole idea about ions is that the ion will, or the atom will gain or lose electrons to satisfy the octet rule, to fill their outermost energy level. Well, sulfur is going to gain 2 electrons. So I'm going to put those in blue. So it is gained those 2 electrons. I need to put a bracket around it then and say, okay, how many electrons did it gain? It gained 2 electrons. So that's where this 2 minus charge right there comes from, those 2 electrons that were gained. Now magnesium. Magnesium's a little bit different because magnesium is an alkaline earth metal, so it has a electron dot configuration of 2 valence electrons. It wants to lose. Remember, metals tend to want to lose electrons. Non-metals want to gain electrons. So it's going to want to lose those 2 electrons. So I told you, you could have magnesium as so, with the 2 plus, because it's lost 2 electrons. But I also told you, probably the more correct way to write the magnesium would be, since it lost those 2 electrons, its outermost energy level is going to be filled. Because when magnesium loses those 2 electrons, it takes the configuration of neon. Okay? So it would take the configuration of neon, so it would have that full outermost, and there's my 2 plus. So you could write that one either way. Now, boron, my next one here is kind of a funky one. It's kind of a funky one. Why? Because when I write boron, okay, we said before boron has 3 valence electrons. So I'm going to put a 1, I'm going to put a 2, I'm going to put a 3 right there. Now, the funny thing about boron, it's going to want to lose those 3 electrons, okay, because it's getting to be a +3. So it's going to lose those 3 electrons. Now, the problem with this that I saw is people would put boron and they would say, okay, it loses those electrons, and then it filled up its outer shell and took a +3 charge. Well, the problem with this is how many electrons does boron have total? How many total electrons does it have? Taylor? 5. It only has 5 electrons to start with. How many are you showing right here? 8, right? So that has way more than what boron has. So the deal with boron, okay, is boron is going along with that exception because it's going to fill its shell with those 2 because it's going to look like helium. Okay, would. Questions on that one? Understand why I can't put those 8 around boron? Okay, my final one here. It's kind of an easier one. It is nitrogen. So I see nitrogen. Olivia, how many valence electrons does nitrogen have? 5. So I say 1, 2, 3, 4. There's my 5. So I can see that this nitrogen wants to gain 3 electrons because I have 1, 2, 3 spots open. So it gains those 3 electrons. I put in the brackets, and it's going to have a 3- charge. Any questions about those electron dot notations? We all right with them?